In this lesson, we will be doing an activity which is an exam-based question which was written in 2023 November. So, that was question 2. It carries on in the next slide. Because they don't fit in one slide, I've decided to separate them. So, we've been given the series 7 plus 12 plus 17 and they go further. So, 2.1.1 says, determine the value of T91. And that is for 3 marks. So there is the series that is given there is that we have 7 plus 12 plus 17. So here what we're going to do, we are given the sum, but they want the term number 91. Remember in one of the videos that I've said that whenever you are looking for Tn from a sum, you must know that Tn is equal to Sn minus Sn minus 1. This means that T91 is equal to S91 minus S91 minus 1. This means that term number 91 will be equal to S91 minus S90. This means that the term number 91 is equal to the sum of the first 91 terms minus the sum of the first 90 terms. So, first of all, we must know what is the formula for the sum. Well, the formula says that Sn is equal to, because it's an arithmetic, we're going to use the sum of an arithmetic, that is n over 2 multiplied by 2a plus n minus 1 multiplied by the difference between consecutive terms. So, what we're going to do here, we must know what is the value of a and what is the value of d. Because they've said that it's an arithmetic, we know that. Let's erase this one. Because it's an arithmetic, we must know what is the first term. A is equal to the first term, that is equal to 7. D is equal to T2 minus T1 is equal to T3 minus T2. What is T2? T2, that is 12, minus 7 is equal to 17 minus 12. So what is 12 minus 7? That is 5. And 17 minus 12 is also 5. This means that A is equal to 7 and D is equal to 5. So we can go further and calculate S91 and S90. Because we say that T91 is equal to S91 minus S90. So let's have some space here. We're going to say that S91 is equal to n over 2, that is 91, over 2, multiplied by 2 times the first term. What is the first term? The first term, that is 7. 7 plus n minus 1, n that is 91 minus 1, multiplied by the difference, that is 5. And we're going to get the answer there. So let's see what we get there. I'm going to punch all that on the calculator. So we get 21112 is the answer. Let me write it below here. The answer that we get there is equal to 21112. And we're going to look for S90. S90 is equal to 90 over 2 multiplied by 2 times 7 plus 90 minus 1 multiplied by the difference, which is 5. So we're going to get the answer here. We can just replace the 91 with 90 and get the answer. The answer is 20655. 20655. So to get the answer here, we can say that therefore we said that T91 is equal to S91 minus S90, and that is equal to 21112 minus 20655. And let's see what is the difference there. We're going to subtract to get the answer. The answer there is 457. So the answer is 457. That is T91. So next time you must know, if you are given a sum and you are requested to calculate the T number 91 or a term number, you must know that the term number is equal to the sum of the n terms minus the sum of the n minus 1 terms. So what is 2.1.2? It says calculate the sum of the first 91 terms. Okay, so I don't want to waste time here. We have said that the first answer is 457. So let's write it. The first answer is 457. So term number 91, S91, we have calculated it, and here it is. So the second answer, they say calculate S91. We have found it. S91 is 21112. So we're just going to write the answer there. Because we have showed it in all the steps, we're just going to write 21112. Then 2.1.3 says calculate the value of n for which Tn is equal to 517. Okay, so here you are calculating the value of n. You are calculating the value of n. Remember, I've said that if they've given you the value of n and you have to calculate that, if they've given you Tn, then you will have to calculate n, which is the position on which you will find the value that is given. Because we're talking about Tn and we're talking about an arithmetic, we're going to say that Tn is equal to a plus n minus 1 multiplied by the difference. We are given Tn as 517 is equal to a, we said is the first term, and we said it was 7, plus n minus 1, and we said the difference was 5. Okay, we are looking for n. So what we're going to do, we're going to say that 517, we take the 7 to the left side, it changes its sign, that is equal to, you do the distribution here, it's 5 times n, that is 5n, it's 5 times minus 1, that is minus 5. And then, what is 517? Let's add all the like terms once more. So I'm just going to erase here and add the like terms. So we're going to say we have 517 minus 7, and this one is going to be positive 5 because it crosses the sign. It's equal to 5n. So what is 517 minus 7 plus 5? That gives us 515. So we can say that 515 is equal to 5n. And then we divide both sides by 5. We divide both sides by 5. And at the end, we're going to get our n. What is 515 divided by 5? The answer is 103. This means that n is equal to 103. This implies that you will get the term number 517 on position 103. I hope it is clear. We're going to move to the next question. So, they said that term number 1 is equal to 3. Term number 2 minus term number 1 is equal to 9. Term number 3 minus term number 2 is equal to 21. Okay, 2.2.1. Show that term number 5 is equal to 111. Okay, so what we can do here, they said that term number 1 is equal to 3. Term number 2 minus term number 1 is equal to 9. So we can say that term number 2 minus term number 1, which is 3, is equal to 9. This means that term number 2 is equal to 9 plus 3, and that is 12. So this is the first term, the second term. Now they said that term number 3 minus term number 2 is equal to 21. Because we know term number 2, we can say that term number 3 minus, that's term number 3 minus term number 2, that is 12, is equal to 21. So we can say that term number 3 is equal to 21 plus 12, and we will get 33. So this means that the sequence which is given here is given as 3 plus 12 plus 33. Okay, so we are going to erase these things. Our main focus is the term number 5, but we know that it is a quadratic sequence. is a quadratic number pattern. We've been told in the given statement. The following information is given about a quadratic number pattern. So we're going to say that I wasn't supposed to put series there. This is a sequence. It's 3, 12, 33. Let's do it like this. It must be 3, 12, 33. Like this. It's not a series. We don't have such thing as a quadratic series. I'm sorry. So let's work on this. Let me write it here so that we can have enough space. That is 3, 12, 33. And we can cross out this. So the one term number 5. We have to know the term number 4. Then we can go to term number 5. So what we can do here is to come with the first differences. These are the first differences. Remember, we've done a lot of these questions. These are the second differences. The first differences, we're going to write them here. So, what is 3 minus 12? That is 9. What is 33 minus 12? Well, that gives us 21. Okay, so we are now going to look for the second differences. We are going to say the second differences. We know that the second differences of a quadratic sequence are constant, or they are the same. What is 21 minus 9? If we can say 21 minus 9, we will get 12. And we know that it will be 12 throughout. Because it's a quadratic sequence, the second differences are constant. And I have illustrated this in one of the videos, that to get the number here, we must add these ones. And to get the number here, you must add these ones. To get the number here, you must add these ones. Okay, to know what is here, you just have to say 21 plus 12. If you can say 21 plus 12, what will you get? Let's do it. 21 plus 12, that gives you 33. And there it is. So, what we're going to do here, we know that in order, a number which you must subtract, for example, 21, you'll receive it from 9 plus 12. Okay, and then this one, you'll get it from these ones. So here we have 33 again. So we're going to say that here is 33. And 33 plus 33, what is it? That gives us 66. And what is 33 plus 12? We must get what is here. So we must add these two. Okay, so we're going to say that 33 plus 12, that gives us 45. And to get term number 5, the one which is here, we must add 66 and 45. So we're going to say 66 plus 45, and the answer will give us 111. Well, that is term number 5. I hope it is clear. What you have to do is to come up with the first differences. We know that the first differences, there's nothing fantastic or fancy about the first differences, but the main idea is here. The second differences of a quadratic sequence are constant. So we know that if here is 12, it's going to be 12 here, it's going to be 12 here. So because they want this one, you can't find it without finding the term number 4 first. So we must first know what is here. And we know that to get this one, you add these ones. To get this one, to get this one, you add these ones. And to get this one, you add these ones. Okay, meaning to get 111, which is term number 5, which they are looking for, you will add 66 plus 45. I hope you understand this. So we can go on and say that the answer there is given as 111. Oh, they said show that. You see, we have showed it. Show that term number 5 is 111. We have showed it. There it is. I thought they said calculate term number 5. But there's no problem. We have showed it. So, show that the general term is given as this. Okay, before I erase them. They are now requesting us to calculate the general term. Okay, we know that for a quadratic sequence, to cut the long story short, for a quadratic sequence, Tn is equal to an squared plus Vn plus C. And I've given you the simplest way, that on the second differences, you just have to say 2a. You just say 2a, and on the first differences you say 3a plus b, and here you will say a plus b plus c. Okay, so we're going to say that 2a is equal to 12 because we said that 2a is equal to the second difference. So 2a is equal to 12. We divide both sides by 2, and a is equal to 12 over 2, that is 6. And we're going to look for 3a plus b now. 3a plus b is equal to the first term of the first differences, that is 9. So 3a plus b is equal to 9. What is 3 times a? A is given as 6, plus b is equal to 9. 3 times 6, that is 18, plus b is equal to 9. And we're going to transpose the 18 to the right side, and we're going to say that b is equal to 9 minus 18, and at the end our b is equal to minus 9. And we're going to say that a plus b plus c is equal to the first term in the given sequence, that is 3. So a plus b plus c is equal to 3. A is 6, b is minus 9, plus c is equal to 3. So what is 6 minus 9? That is minus 3. Minus 3 plus c is equal to 3. And we are now going to add the like terms. We're going to say that c is equal to 3 plus 3. And at the end, our c is equal to 6. We can say that tn is equal to a, which is 3. Is a is 3 or what? Let's see. What was a? A was 6. So we can say that it's 6n squared minus 9n, that is b, plus 6. Let's see if it's the one which they are talking about. It's 6n squared minus 9n plus 6, and that is correct. So this is how you have to calculate an equation for the nth term of a quadratic pattern. You just follow the same procedure. There's another method of using simultaneous I have highlighted in one of the videos. If you are comfortable with using it, you can use it, but I promise not to use it because most students are not comfortable with the idea of simultaneous. So we're going to move to 2. We have proved this one, and we are now on 2.2.3. It says that show that the pattern is increasing for all n is an element of natural numbers. Okay, so what you have to do here, they say show that the pattern is increasing. Okay, so we've been given the expression which was tn is equal to 6n squared minus 9n plus 6. So there are many ways in which one can do this. What we can do in short terms, we can check what is term number 1, what is term number 2, and what is term number 3. If really the sequence is increasing, the pattern is increasing, we can say that, okay, therefore the pattern is increasing. We have to substitute t1 is 6. Where we see n, we will plug 1, and that is squared minus 9 times 1 plus 6, and the answer there is 3. And term number 2, I think we have calculated the things, we are just repeating. So we're going to plug 2 here, and we will get 12. And we plug 3. This term we plug 3. And we get 33. Okay, so we can go further and plug T4. Just for interest's sake, we can plug T4. And that is 66. So what do you observe here? What do you observe? You will get full marks if you approach it this way. The pattern is increasing for all natural numbers. We can see that these numbers are increasing. They are not going down. They are increasing. This is how you can do it, and you will get full marks. Or you can use the method of the turning point to show that where it turns, it will increase rather than decreasing. I hope you understand this. But the simplest way in which I could explain this is that you have to substitute the values of n. Remember, n stands for the position, and these are the values of n here. These are the values of n because it says tn. So t1, where we saw n, we plugged 1. So we substitute the values of the natural numbers 1, 2, 3, 4, and we can see that indeed the pattern is increasing. I hope it is clear to everyone. Thank you for watching.